is the lesson for Chapter 10, Section 3, Quotient of Powers, Property, Day number 2. So to take a quick look at our rule again, here we end up seeing that when we're using the quotient of powers property, we subtract the exponents. So we took a problem like this one here, which had 10 to the 5th over 4 to the 5th over 4 to the 2nd, and we subtract the exponents. Again, it worked this way because if I had 5 4s on top of the fraction and 2 4s on the bottom of the fraction, we'll end up seeing the 4s cancel out. 2 of the 4s, both one on top and two on top and 2 on the bottom, will cancel out, leaving us with these 3 4s on top of the fraction. So we're going to use that same concept with this problem here. We are taking the 5s and writing them out, 5 to the 12th over 5 to the 9th, and then we look at the c's, c to the 10th over c to the 9th, and then we just have this 1d squared that's on top of the fraction. So we're taking out or canceling these 9 5s on top of the fraction. So I'm going to subtract 9 5s from the 12 5s, and then do the same thing here. I'll subtract 9 c's from the 10 c's. And so what that'll leave me with is 12 minus 9 makes 3, so 5 to the 3rd power, and then 10 minus 9 makes 1, so c to the 1st power, and then d to the 2nd power. And so I can multiply out these 5s, and that would leave me with 125 c d to the 2nd. Over here, same sort of thing. I'm going to cancel out, or I'm subtracting the 8 x's from the 15 x's on top, and these y's. I'll subtract out 3 y's from the 9 y's on top of the fraction. Then I'll subtract the 3 y's from the 9 y's on the other side of the x's. So if we take a look at y to the 9th minus 3, so we have x to the 7th power, y to the 6th power. Again, you can see it if you write out 15 x's on top, 8 x's on the bottom. These 8 x's will cancel out 8 x's on top. Same thing here. Y to the 3rd is going to cancel out 3 y's on top of the fraction. That's why I've got 7 x's left on top, 15 minus 8, and 6 y's on top as well. Y to the 9th minus 3 y's will leave me with 6 y's. So let's take a look at the other types of problems that we might end up seeing. And here we've got 2 different problems. It says sound intensity. The sound intensity of a normal conversation is 10 to the 5th times greater than the quietest noise a person can hear, where the sound of a jet taking off is 10 to the 16th times greater than the quietest noise a person can hear. So they're comparing these 2 different amounts to the same aspect, the quietest noise a person can hear. And so then it says how many times more intense is the sound a jet taking off than the sound of a normal conversation. So because they said how many times, they want to find out some number times by 10 to the 5th, which is the normal conversation, will equal the jet 10 to the 16th. So how many times a normal conversation, how many times greater a normal conversation is the amount of the jet, is what they want to know. So we want to find out what this value is. So basically what we're going to end up doing is dividing by that 10 to the 5th. So this is our problem we've got to set up. So we're going to take out 5 10s from the 16 10s on top, and that's going to leave me with 10 to the 11th times greater. So let's take a look at our next problem here. It says there are about 10 to the 24th stars in the universe. Each galaxy has approximately the same number of stars as the Milky Way galaxy. About how many galaxies are in the universe if the Milky Way has 10 times 10 to the 10th stars in it? Okay, so we'll start off with the universe. There are 10 to the 24th stars in the universe, and then it tells us that about how many galaxies are there if there are 10 times 10 to the 10th stars in that galaxy. So what we're going to end up doing is we're going to cancel out the number of stars, and we're going to end up doing that by dividing by the number of stars there are in the Milky Way. So 10 times 10 to the 10th per galaxy, stars per galaxy. And so what we'll end up doing is canceling out the stars, and that'll leave us with the number of galaxies. And so we end up simplifying this expression first. So I've got 10 to the 24th over 10 to the 11th. I got that by adding this 110 to the 10th, to the exponent of 10 to the 10th, because I've got 110 and 10 tens being multiplied, which would make 11 tens. And so now I can go ahead and subtract out the 11 from 24, and that would leave me with 13. So 10 to the 13th galaxies is what we would end up seeing there. So those are the types of problems you're going to see on tonight's homework. Good luck.